Right, this is the last video of this factoring series. All right, so let's take a look at a few highlighted questions. Let's start off with number 13. The reason why I picked number 13 is because it is clumsy. It's wordy, it's so long. All right, so how do we do this? All right, now, first, anything special? Ah, I see y squared among all three terms. Anything else? The numbers? No, I don't see any numbers that are nice. Unfortunately, all right, unfortunately. Now, however, something caught my attention. Something really caught my attention, and that is, 9 and 100. These are perfect squares. Like that got me wonder. Is it one of those special cases where you have the a square, b square? Now, that's where you want to start because if you don't start there, life is going to be miserable. Okay? They give you all these things on a silver platter, entertain them. Now, so how do we know if it is or if it's not the case? First, look at these numbers differently. Okay? What is 9x squared? Consider this as 3x parentheses squared. What about 100? 100, it's 10 squared, of course. Now, the final question is 60x. Is 60x 2 times this and this? Because if it is, bam, that's a special case. Okay, that's the a squared plus 2ab plus b squared. So 2 times 3x is 6x, and 6x times 10 is 60x. So this is indeed 2 times 3x times 10. We've got our special ticket right here, a squared plus 2ab plus b squared. So now we're like, ooh, thank God. This is so easy. Gotta be sensitive. It's all about number sense. That's why at the very beginning, all right, of the video series, I said you gotta open your eyes. You gotta be sensitive. Okay, that's how you do it. Ooh, x to the fourth power. Again, all right, again. Oh, this is gonna be ugly. Now, how do I know? I factor it in my mind already. That's your target, all right? You look at the quadratic trinomial, you can factor it in within 5 seconds. Of course, the easy ones. And this is an easy one. Okay, all right? Because why? Because -1 times -16 is positive 16. Why? Because that's how you get -16x squared minus x squared. That's how you get -17x squared. Are we done yet? No. Why not? That's a squared minus b squared, a squared minus b squared. You have more to do over here. X plus 1, x minus 1. That's from here. All right? And then you have x plus 4, x minus 4. That is from here. Now you're done. Very sensitive, okay? All right? Now, again, like I said, if you don't see it, no problem. Learn it. There's one thing I want to remind everybody here, and that is, how do we learn language? Language, it's learned by usually one single means, and that is repetition. Repetition is in listening, repetition in reading, repetition in speaking. The more you see, the more you say it, the more you listen to it, you get it. Okay? All right? Same thing with math. Okie dokie. All right? Number 5 and number 6. Now they look very similar, right? They look very similar. Now, first, get a 2 out. So you have n squared plus 9. Anything else we can do? Nothing. How come? It's n squared plus 9. Can we do anything about it? No. If it's a squared minus b squared, you could. This is a plus. Cannot do it. Okay? But for number 6, after you take out the 2, after you factor out the 2, you could do something further because it is a squared minus b squared. So n plus 3, n minus 3. Okay? So I picked these two to show the contrast. Make sure you are very sensitive to a squared minus b squared. Okay. Oh, by the way, in case you want to find some utility, some value of all these factoring. SAT is going to test you the skills of factoring. If you are not up to your game, you pay the price. Okie dokie. All right, what can we do here? I can see a 5 being a common factor. I can see a y being a common factor. So I get 4y squared plus 9. Can we do anything further? Nope, we cannot. But now, what about number 11? Ooh, see how they are like parallel with each other. 4y squared minus 9. Ooh. And you see something special. 2y plus 3, 2y minus 3. Okay? All right? A squared minus b squared. A squared minus b squared. All right, what about this? I think common factor here it's 2, right? And also h squared. So 2h squared, it's being factored out. What's left? 25h squared minus 16. Oh, can you see it? Can you see a squared minus b squared? Okay, I hope, you know, the recent few problems, okay, having this repetition, you can get a hang of it. Okay. Ooh, what's this? Let's take away the 2h, since they're both even numbers and they both have h in it. 49, h to the 4th power minus 1. Okay, ooh, can you see? Again, a squared, b squared. Okay, all right. Now, depending on the teacher, usually we're done right here in Algebra 1. But now, if you're in Algebra 2, especially AAC, Algebra 2, this is not your final answer. Why? Because this is also a squared minus b squared. Now, you might be like, whoa, 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 7 is not a perfect square. Yes, it is. What? How is 7 a perfect square? Well, it's a perfect square of square root 7. Okay, so I'm going to let you ask your teacher and see if your teacher requires it. All right, I'm going to grade it out so that you know this is for Algebra 2 only. But in Algebra 2, you expect this. Now, since we are spilling the beans of Algebra 2, let me tell you let me give you one sneak peek. Now, if you have x squared minus 9, it's going to be x plus 3, x minus 3. Okay, a squared minus b squared. What if you have x squared minus 7? It's going to be x plus root 7, x minus root 7. So what we're saying here is this, okay? The transition was, well, earlier I gave you these little numbers right here. I said, hey, you go ahead, look at these perfect square, you know, 9, 16, 25, you know, 36, 49. Okay, know these perfect squares. They're very special. Be aware of it. In the future, you need to understand like every single number is practically a perfect square. It's just that it's a perfect square of something ugly, but yet they are perfect square. Okay, so that's it. All right, that's it. So that's the skills that you need. All right, if you have any question, let me know. All right, see ya. Bye-bye.